All right, so a deposit of $100 is made on the first day of each month in a savings account that pays 6% interest compounded monthly. Find the balance of this annuity after 4 years.
Okay, so it's not an infinite series because you have 4 years, right?
Right, it's not infinite. We're ending after 4 years. But we do want to find the balance, so we're dealing with a sum, right? Because a sum of all of that money put together.
So do a sigma with a 4 on top.
You could, except for I'm just going to use an S. But be careful because that $100 is being made on the first day of what?
Every month.
Each month, and it's my interest is compounded what?
0.6%.
So
Compounded monthly. So everything's in months except 4 years. So let's go ahead and switch that. So let's make that 4 times 12 is 48. All right. Remember, we're looking at our formula. We know it's infinite, so we're going to use the formula that sum is equal to a sub 1 times 1 minus r to the n over 1 minus r. And it's supposed to be s sub n. Sorry about that. All right, so I need to know, we know n. What is n? 48 months. Okay. So we can go ahead and plug that in. Do we know our first term?
Would it be 1?
No, it's not going to be 1.
No.
Well, we'll look at it. And do I know r?
No.
No. And I know n is 48, right?
Yes.
All right, so we got to go do some stuff to do this. Let's go back and let's look. It says $100 is made on the first day of each month. So that very first time he puts money in the bank, how much is he putting in? And how long is that money going to be in the bank, that $100?
30 days.
wait, what?
Well, before he puts another one, but that $100 is going to stay in that bank for 48 months, right? So let's go find what that $100 is worth itself at the end of 48 months. So I'm going to go find a sub 48. All right, so to find this, it's kind of like when we did our interest formula from before. We said the ending amount was equal to the principal times 1 plus your rate over the times compounded times n times t.
Something like that. Yeah.
All right, but we know our NT is going to be the number of months it's sitting in the bank, okay? So NT on this one's automatically going to be a 48. We're not going to worry about multiplying because it's 4 years at the 12.
Okay.
But and so we'll keep that pattern going when we find others.
Is R just 6%?
R is a 6%. So my principal is how much he's putting in.
100.
$100 times 1 plus, what's my interest rate? 0.06 over the number of times compounded? 12. It's compounded monthly. And then, I'm sorry, because the interest rate's per year, so it's the number of compoundings per year, okay? Raised to the NT, which we said is going to be the 48 months.
Just stick this in the calculator.
So first I want to show something. Let's actually just put the parenthesis in the calculator. What is 1 plus 0.06 divided by 12?
Miss Fitz, would you also put 12 on the 48?
Wait, I got 100 again. Oh my. I got 100. I don't know what that means.
All right, so let's just type this in the calculator right there. What is 1 plus 0.06 divided by 12?
1.005.
Good. 1.005, and then be raised to the 48.
I'm gonna do it.
And I know y'all like to figure out what that number is, so what is that?
I got
What?
127.0
1.2704.
what?
Oh, wait.
489.
Times 100. I'm done. 0.048.
So 0.5?
Yes.
All right. So that $100 they started out with, the very first deposit at the end of 4 years is now worth $127.05. So you earned $27 on it. All right. What about the next deposit he makes? So now how long is that one going to be in there?
47.
47 months. So let's find that.
What?
Now,
Subtracted 1.
notice everything's going to be the same except the number of months, right? So I'm just going to rewrite it as 100 times 1.005 raised to the 47. $42? All right, not worth quite as much, but it wasn't in there as long, right? And we could keep going on that, couldn't we? But I have enough there, I can find my R value.
0.995.
Because I can divide. Now, be careful. So, my R is going to be my A sub 48 divided by my A sub 47. Now, you can plug those numbers in if you want to, or you could just look at the equation we had. We had 100 times 1.005 raised to the 48. I'm going to divide that by 100 times 1.005 raised to the 47. Well, your 100s will cancel, right?
1.005.
And your exponents, because your bases are like, when you divide, what do you do with your exponents?
Subtract
So you would get 1.005 to the first, which is,
1.005.
so my common ratio was that stuff we had in parentheses, wasn't it? So it was the 1 plus the interest rate over the number of times compounded. All right, so I know R. What else do I need?
A sub 1.
I need A sub 1. So let's go find it. You can't say now A sub 1 is 100. Because remember, they're making the deposit on the first day of the month, and we're looking for the end of that month, in the 48th month, okay? So you got 100 times 1.005 to the first. Which gives us 100.5 or $100.50, I mean.
Yes.
All right. So now we can plug in. We know our first term is 100.5 times 1 minus, you said R is 1.005 raised to the n, which we know is 48, over 1 minus 1.005. Now for the fun part, getting that all typed in your calculator correctly.
Can
Alright.
we put the parentheses and then multiply? Or is that
Yes, you can put parentheses. Oh, wait, no, do times and then multiply. All right, so put that in. Let's see what we get. Okay, and if you type it in correctly, you get $5,436.83.
So is this interest equation going to be showing up from now on, or was it just this one?
No, it was just this one.